I'm going to start first by just having a little introduction to the summer work. I mean, a lot of actually folks on this call are mentors, so I don't think I have to go too far into or students or somehow have worked on the OSRE activities. Everyone can see my screen, correct? Yes, there we go. Oops, did I go there? I might have skipped something. No, okay, great. All right. So for those of you, everyone I think on the call has a pretty good understanding of the what we were doing over the summer as part of this open source research experience. Hold on one second. I realize that my screen is, you can't see me. Now you can. But it's definitely it's a really important part of our OSPO open source program office activities here at UC Santa Cruz. And a lot of what we did, I find, and one of our core activities and that we want to do as part of the OSPO is creating this idea of creating partnerships. And I think the OSRE has been a great way of getting to work with really interesting folks and interesting projects. And because of us, of a couple new programs, including this Summer of Reproducibility, we've been able to work with open source initiatives and reproducibility initiatives, both inside and outside of the UC system. And I think that was definitely a fun part of this summer in particular, where we got to expand more than we had in the past. For those of you who are new to OSRE, and I think there's still a couple of you on that may benefit from just a little bit of an overview of what the OSRE is and has been over the last few years. It is really our kind of, we used Google Summer of Code as a basis for creating this program, and part of it, and a lot of it started, of course, as us being Google Summer of Code mentors beginning in 2018. And we learned a lot from that experience and wanted to really expand what we could do with, and so not just only be Google Summer of Code mentor organization, which has been a great experience and we continue to be one, but also we are want to be able to expand it even further and use other sponsorship and other methodologies to have even more students and mentors connect and be able to really jumpstart numerous communities, contributor communities, and get more students working with more mentors, but it's still being able to leverage global outreach programs like GSoC in order to do it. So as most of you know, because you've all went through this, we have this project list, which your students would pick a project from, a project idea from, and then expand it into their own proposal. And then all of the mentors get to go through those proposals and pick the students that they think will work best with them over the summer. And I think that's been a really, and I feel, and I love to hear students, since we have a lot of mentors on the call, maybe also at once we see all the videos, we can actually talk a little bit about how that process worked for them and if they felt that was a great way, because ideally that is how you get to know your students and the students get to know you, so you know that you're a good fit for the summer. Again, as I said, GSoC was our initial blueprint, but we did see that there was folks that kind of got left out of GSoC, and so and in various ways, sometimes it's the type of contribution they want to have that maybe didn't fit nicely into GSoC. Sometimes it's the type of students. For instance, we really aren't supposed to be having linking up students from within UCSC with other UCSC mentors, which we thought was, we didn't want to have that as a hindrance. We actually worked with a great high school student this year. She presented on Wednesday. On Wednesday on our day one. And we couldn't have done that under GSoC, for instance. And then, of course, there was the Summer of Reproducibility also gave us the opportunities to work with an even wider scope of people. The two new things we did this year was the HBCU Catalyst program that Emily led, and that went great. And that was actually for students coming here. And if we have time, maybe at the end, Emily can talk a little bit about that. We definitely have links and info about that on our website if you're interested. But the other big one, of course, and which is represented in the group of students that have lightning talks today, is the Summer of Reproducibility. And one student, I think one student was technically Summer of Reproducibility. Another one kind of, was GSoC, but also working on reproducibility. So I kind of count Luiza a little bit into the Summer of Reproducibility group as well. Again, and so the Summer of Reproducibility, which is the kind of the newer part of OSRE this year, looked to simplify reproducibility in computational research, and again was connecting the mentors and students and helping building tools and capacity within the students working on it, and also assisting the mentors in furthering their own research. So again, this is kind of a repeat of that last slide, but it gives you an idea of what we were working on. And like I said, it really allowed the OSRE to broaden the range of student and mentors we got to work with. And again, I didn't say at the beginning, this was all based on an NSF grant. Repredo, actually, that's up here on the slide. It's part of our NSF Repredo project, which is in collaboration with the University of Chicago and New York University. And again, and we had mentors from also, aside from other places, of course, had University of Chicago and NYU mentors this year. And so again, the Summer Reproducibility, there's a lot of you know about this already because you're mentors from that program. But it definitely was really interesting for me, and I learned a lot trying to run the program as a whole this year. And I'd love to have feedback particularly from the Summer Reproducibility focused mentors, who I feel where, whether there was any aspects that was maybe easier to do a little bit of an adjustment for next year, because we are doing it next year. So we have funding through for 3 years and hopefully beyond that for this program. And just a quick evolution, just to show what we were doing when we started in 2018. Like I said, we had 2 or 3, 2 and then 4 GSoC students in those first few years. We created OSRE in 2020, kind of to, like I said, to expand the pool of students. And every year we've kind of gone up. And I don't know what happened to my line on 2021, but we didn't. Yeah. And each year you kind of see what different things kind of changed. And so it's definitely evolving. 2022, we started using other UCs and asking other UC campuses and other projects to be mentors. And again, this year we had a big jump with the Summer Reproducibility and Catalyst program added. And so you can see the numbers and the little fish. And I think Emily was actually who gave me the fish idea the first time. I think this might have been her slide that I stole. But and it was, you really see the huge impact, and then the impact of increasing the UC student, the UC mentors, and then the Summer Reproducibility as well. So a big impact on the numbers that we were able to work with. So these are some of them. Some of the students, and these this is more like just to show the blog posts, and we really like to highlight all the work of the students, and these are from our website. They should each of them have at least 2 at this point blog posts. They should have 3, so I think some of them are still working on their final blog posts, and those hopefully within the next couple of weeks we'll see final reports from all of them. And it was great because we have them from all over the world. So we have them from all over the world. We also have faculty, researchers, industry partners, and grad students all being mentors together. And you see the kind of the breakdown of that. Again, these are UC faculty as well as, and this is the pictures is not a full list. Not everybody. There's more of them if you go to the website. But it was a good mix, I think, for the mentors we had this year as well. Let's see, did someone have a question? Okay, thank you. So some things we discovered this year, and actually have discovered So it's not just this year. So that I don't think it's surprising that university researchers can be really, really great mentors. I think we definitely have seen that since the very beginning, but they do need some support. And that's what we like to do. We basically want to enable more and more researchers to be able to have a good mentor experience. And also creating more of a cohort. And we tried to do that a little bit this year. I think next year I'm really going to make more effort to create like a support system for mentors who maybe need a little bit of advice from a cohort. And also this, I think it's really important that we are able to bring together mentors and students who may never have found each other, but really, really have benefited from being able to work together. I think that's my slides. Oops, that doesn't want to work today. There we go. All right, so I am going to now, so these are the 4 that we're going to see today. We have about a half altogether. I think there'll be about a half an hour. I was unless there is a need for someone to like break off before the end of that half an hour from mentors or so, I was hoping to just put all the questions at the end. If that's a problem, just let me know. And this was the order that I was planning on going on. Unless at least that was my plan. So we'll talk here first from Kangrui. Gosh, I actually speak Chinese and I can't say his name properly. I apologize. Kangrui, real. Okay, I'm getting really embarrassed. I'm going to be, all of my friends who know I speak Chinese are going to make fun of me over that one. Anyways, that is was a student working with Sandeep and Ray, and I think Ray is on. Yes, Ray's on the call. And again, that was he was a summer reproducibility student. And also we have Jack Luar, who was working with our OpenROAD team. And he was under GSoC. And when I say they're all OSRE students, but these are like the sponsored programs that they went through within the OSRE. And so they were with, so Jack was within, kind of working through the GSoC system. Luiza is, I think, the interesting one because Luiza was a GSoC student, or a GSoC contributor, but also working on reproducibility. And she was we had a couple of students who were kind of crossing both of those this year. And then Mahnoor Ismail also was a GSoC student working with Jesse, who's on the call as well, and in the OpenRAM project, which is out of UCSC. Okay, so with no further ado, let me see if I can. Let's see what I can do. Okay, and thanks to Jesse, now I know actually how to properly share and get a video to work off of my Zoom. And please let me know if this actually is good.
Hello everyone, I'm happy to be here to give you a presentation about our summer project titled as Concept-Drift Detection with Large Language Models. I'm Kangrui. My mentors are Sandeep and Ray Andrew. Firstly, let me give you an overview of this presentation. I will firstly talk about the motivation of this project, like why we do concept-drift detection and why we choose to use large language models. Then I will introduce some technical background, after which I will talk about our methods. This will be the focus of this pre. Finally, I will show you our experimental results, sum up our project, and discuss some possible future work. Alright, let's begin. The ultimate goal of our research is to accurately predict the performance of HPC clusters. By doing this, we can make decisions about job scheduling, optimize application, and plan capacity for facilities. In all, the accurate prediction of HPC performance will benefit us a lot. However, we also encountered many challenges during this process. The main challenge in predicting HPC performance comes from both the hardware side and the software side. The heterogeneity nature of hardware, its UU degradation, replacements, and unexpected hiccups as well as the ever-changing software landscape with its upgrades and downgrades can cause data drifts in the data stream we want to predict on. This results in a bad performance of our predictor. Then, a drift detector is in urgent need, because usually, if everything is smooth and there are no drifts detected, our predictor would use the new commit data for training. But when drift shows up, we need to conduct a full retrain, which means that we need to reinitiate all the parameters of our neural network-based predictor. This step isn't just busy work, because getting a good initial parameter is the key for our NN module to fast adapt to the drifted data. Why we want to use large language model in drift detection? Well, firstly, the landscape of LLMs is in a state of continuous evolution. The relentless enhancements foster a robust ecosystem conducive to rapid development, which might be very helpful for drift detection. And second, our experimental results show that large language model might perform better than traditional methods. The performance is very promising. Also, LLM could handle various input types and provide rich or explainable outputs, while traditional statistic methods may only be able to take in numerical values. Also, we choose to use non-material in the experiment. This is because of its both performance and accessibility guarantee. And the non-material is flexible to fine-tune. We can use various techniques like quantization and LoRa to fine-tune non-material in various sizes. Well, let me give you some technical background. There are three types of data drift. For real concept drift, the functional relation changes, but the input and the output stays in the same domain. And for virtual concept drift, the output changes, but the input and the functional relation stays the same. And as for domain drift, the input, functional relation, and the output all stays the same. And the way we are doing the drift detection, most of the time we are detecting the real concept drifts, which is the hardest one for us to handle. Also, there are four types of concept drifts in terms of time, as you can see here. The sudden drift, gradual drift, incremental drift, and the recurrent drift. Also, I'd like to introduce some traditional drift detection methods. They are Page-Hinckley, EDDN, HDDN, K-swing, and HDDN-double. Page-Hinckley and K-swing are computationally efficient. EDDN is sensitive to small changes. HDDN is robust but requires significant resources. HDDN-double is suitable for detecting gradual drifts. The choice of method depends on the specific requirements of application, and the results of the data collected from Alibaba traces show that the performance of these methods are all basically good, but there's still large room for improvement compared with our target. And here comes Llama 2. Llama 2 is Meta AI's open source large language model. The parameters ranges from 7 billion to 70 billion, and it's been trained on 2 trillion tokens with a context length of 4K. It's fine-tuned over 1 million human annotations, and it's very powerful. The 70 billion version outperforms most of the open-source large language models in various benchmarks. Basically, it's an auto-regressive language model. Now here comes the matters part, and let me introduce you the general case of applying a large language model in drift detection. Let's consider X as the original input. Now we introduce a prompt function P, which transforms X into a templated input suitable for a large language model. And let's denote this large language model as N, where both the input and the output are strings. Following this, we have an extractor E, which is tasked with pulling out key information from the output generated by, and the answer we seek from this approach is reflected as Y, which is obtained by applying the extractor E to the output of the large language model N, which in turn has been fed the prompted version of the original input X. We apply large language model in drift detection in 2 scenarios. In the first case, large language model is treated as both a classifier and a drift detector. Here, X is an array of data points from x1, y1 to xn, yn. X is the feature and Y is the label. Other parts basically function the same as before. And here, the final output Y would be an index, showing the location of drift points in X. Y is greater than or equal to 1 and less than or equal to. In the second case, large language model only performs as a drift detector, which is assisted by a predictor. And here's how we do. Let n be an array of data points, which is like previous x. And x is the array consisting of features of it, and y be the array consisting of labels. And we say if C is a predictor, we get the predicted results of Cx as y, and we get the accuracy. The accuracy is now the input prompt and the large language model. P, M, and E are all the same as before. And we can y a Boolean value that shows whether there's a data drift happening x, y equals to 0. And here are the sample prompts we provided for large language models. For case 1, you can see that we require the large language model to give us an index. And for case 2, you can see that we let the language model to answer good or bad. Good means there's no data drift happening, and bad means there exists data drift. Then it's the experiment part. We use the synthetic data stream for experiments. This is a simulated dataset, which could test our framework on abrupt concept drift and gradual concept. For the metrics, in case 1, we used the accuracy. Given a data stream of length n, we feed them into the large language model. If the index the large language model predicts lies in the drift transition period, then we say the prediction is correct. Otherwise, it's false, and we calculate the total. In case 2, we use the delay time, true positives, false positive rates, false negative rates as our comparable metrics with the previous method. As you can see here, there's a window move from start to the end of the whole data stream. Each time, we feed the predicted results of the data within the window into large language models. And mainly to tell if there's a drift, we will set an accept interval. If the detection of the data drift is within the interval, we would consider the prediction as true positive. Otherwise, it would be false negative or false. The experimental result of case 1 highlights that the Llama 2 13 billion model outperforms other models by achieving 40% accuracy rate across nearly all 4 types of datasets. This is a very promising, and the 30 billion model was not evaluated in this experiment, but we believe that performance would significantly surpass that of the current SOTA. In case 2, we present a comparative analysis between our LLM-based detection framework and the prior traditional statistic framework. It's evident from the results that our method performs the best across all evaluated metrics, demonstrating its use. And we conclude that this work pioneered the application of large language models in drift detection tasks, presenting a novel approach in this domain. And we demonstrated the effectiveness of LLMs in drift detection when augmented with an online stream trained predictor, showcase the synergy between LLMs and other machine learning. Also, the performance limitations of large language models when solely utilized for both prediction and drift detection is that highlighting areas for improvement within the large language model architecture or function. We acknowledge the challenge of high inference time with large language models, a crucial factor for real-time application. And for future works, we will say that the performance optimization, the model improvement, and some extended application very promising. And also, there could be more evaluation. That's all. Thanks for your listening.
All right, great. Sorry about that sound fluctuation. I do think it was from the video, and I hadn't run the whole video to check it. But Sandeep and Ray actually asked if they could do any Q&A or comments right afterwards, because I think they had to leave. So I'd open the floor for questions, but also considering the sound issue, if either of you the mentors wanted to maybe add any extra explanation, if there might have been anything that was lost and hard to hear, feel free to, maybe if you want to actually start with that, any comments you want to make about or the project overall, maybe that's a good place to actually start. Sandeep and Ray.
Yes, certainly. Thanks for the opportunity to work with OSRE this time. So yeah, sorry about the low voice in the presentation. But overall, our goal was to see if we can use large language models for drift detection in data. Typically, the drifts are in many types, right? So it could be concept drift, or it could be the feature drift. So we were envisioning that language models could be a way in which we could have a common framework to do that. With this project, we were specifically looking for the systems data and trying to see if we can detect a specific type of drift called concept drift. And our preliminary results showed us that it is in fact a good approach to do that detection. And for this study, we used some synthetic data, which is kind of the benchmarks that are used across this community. Very happy to answer any questions.
Thanks. Any questions about the project itself, or did you have any maybe comments generally about how working with the mentor in the mentor mentee setting on this type of project worked for you? Any kind of any general comments or about your mentee's work and that you'd like to kind of add to the on top
this? I mean, so it's good because this is a very fast moving field. So we kind of had to switch between approaches as the progress happened, even during the time the internship was going on. So it was a bit challenging in that sense, but it's also learning experience for us.
Good. Well, I'm good to hear that it was learning experience. Not that it was challenging. And Aldrin made a comment. He had to join late, but he was actually really interested in connecting offline. So we're happy to connect folks who want to have further conversations as well.
Definitely. So we are trying to write up a workshop, a NeurIPS workshop paper based on this work. So we can share it with anyone who's interested, or we could also talk offline if you'd like that.
Great. And any other questions or comments for the team here, with the mentors that are on the call? Right. And Kong was, I guess, he was he said he couldn't, he had some issues trying to make it today. So, but he did say that if people wanted to reach out specifically and ask questions, that they could email.
Yeah, yes, definitely. So there was one conference deadline today morning. So if he was like completely occupied working on that submission.
No, he told me. So it was like, I told him, like, don't worry about it. I gave him the opportunity to, even if he had wanted to skip recording it and just come live, whichever worked out for him. But I totally understood. So I appreciate that you, the two of you, the mentors, could show up for this. So
yeah. I should really thank you, Stephanie, for making this happen. This was a really good experience for us as well.
Oh, good. That's really glad to hear. I hope for those mentors that are on the call, I hope to have kind of a wrap-up session. It's just been crazy with doing the symposium as well. But it'd be great to have some just a chance for people to feedback kind of and hear things that people thought were great, what could be improved for next year as well. So, but good. Thank you for the feedback on that. So, all right. If we don't have any more questions for Sandeep and Ray, I was going to move on to the next lightning talk, which was Jack. And if people have questions while they're still on, I mean, obviously you can use the meeting, and the chat function as well to keep the questions going. All right, so the next one is Jack Luar, who worked with our OpenROAD folks this year.
Greetings, everybody. I am honored to introduce my Google Summer of Code project with OpenROAD. My name is Jack Luar from the National University of Singapore. I am mentored by Indira and Vitor from Precision Innovations. Documentation is often overlooked and underrated, so today I would like to discuss on how we improve documentation and ease of usage for an open source project. Before we begin, allow me to introduce OpenROAD. OpenROAD is a leading open source foundational application for semiconductor digital design. It has full support for no human in the loop flow from RTL, meaning Verilog circuits, all the way to GDSII, which are manufacturable design formats used by foundries. Commercial electronic design software is often expensive, not to mention the closed source nature of their algorithms. OpenROAD seeks to address this limitation by making chip design easy, free for all to learn and apply. So whether you're a student, learner, researcher, or industry practitioner, you'll be able to use it. To date, in collaboration with eFabless, we have successfully contributed to over 600 tapeouts in the 130 nanometer and 180 nanometer technology node. That is testament to the growing open source EDA community, and we hope to see this trend continue growing. Now, let us get into our summer project proper. Firstly, we have open installation of OpenROAD for 9 major operating systems. As we know, installation is often the hardest barrier for newcomers to acquaint themselves with a tool. The first thing we did was to check all installation scripts to make them up to date, and also give more support for Docker-based commands, which is extremely flexible and runs on all operating systems. With this change, we have observed reduction of installation-related GitHub issues posted on a weekly basis. Secondly, we have also inserted missing documentations on various steps in the design flow. On the right, you can see almost 20 tools that are being documented, along with helpful information such as defaults and data types. The goal here is to embed the tool documentation with as much useful information as possible, so the end user does not need to do too much research on their end to get started. We have also introduced more consistent formatting. Rather than having all arguments for a function under a common table, we separated out into developer arguments and developer commands. This is to further make our documentation more beginner-friendly to read, while not alienating our technical user base. We have also added sections for example scripts and regression tests. This is to help onboard newcomers to each tool of our flow. Thirdly, we have also introduced extensible documentation formats. Now, what do we mean by extensible? It means that we have created an infrastructure which is easy to use for developers and allows for greater maintainability. Our goal is to create something that requires minimal changes to add content for documentation. So how do we do this? We introduced 4 initiatives, namely the warning/error messages glossary. We noticed that people were searching for error and warning messages, but our documentation did not have them. So we added a page where all the error and warning messages came with the relevant code line number, and this was to be generated automatically. On top of that, developers can add useful debug information to help the end user find out what's wrong with the error message. Next, we have also introduced automatically generated Doxygen pages, which integrates nicely into our C++ and Tcl source code framework. This automatic generation will make it much more convenient for developers to just insert comments into their source code and allow Doxygen to generate documentation automatically. Next, we introduce cloud-based packaging. It is important that our framework is able to be runnable on cloud and the ever more popular notebook format. Our Collab-based notebook was designed with this in mind and allows for easy transfer to other notebook providers with similar some modifications. Lastly, we have the changelog workflow, which can be triggered manually. For our open source project, we have chosen not to do software releases. This might mean that it can be difficult to track changes between commit numbers. Adding this workflow will generate a changelog periodically that can help newcomers track the changes to our code base easier. And as you can see, we have grouped it by month, so we can actually have a nice overview of what has changed on the code base on a monthly basis. Finally, here are some of the thoughts we have in the works. We are discussing the potential of creating a chatbot whose purpose is to answer user queries. We were thinking there are lots of domain knowledge in Slack channels, GitHub repos, and so on. So why not create an LLM-based chatbot? So this is currently in progress, so we'll update you as we go along. With that, I'd like to thank everyone for listening to my presentation. I would also like to thank Google and UCSC for making this entire open source research experience possible. I would also like to thank the OpenROAD team, my mentors Indira and Vitor, for their advice and support throughout the project. Do support us by giving us a follow on our social media. Thank you once again.
All right. And I also wanted to say, while I'm getting the next one open, that if people want to ask questions of the mentors who are on during the session, feel free to use the chat to do that. Luiza is next. And Luiza is also online too to answer questions.
Hello everyone. My name is Luiza Hesketh, and today I will be presenting my Google Summer of Code project called Advancing Reproducible Science Through Open Source Laboratory Protocols as Software. This project was developed under the mentorship of Daniel, Bryce, and Timothy Fallon from UCSC. So let's get started. So in a nutshell, replicating a laboratory protocol in biotechnology research is a challenge. That is because the operator, the researcher, usually cannot go past the softwares that operate liquid handling machines, usually used to operate those protocols, to execute the laboratory protocols. Each machine has their own locked software that is very difficult to get by and to operate. So it requires an automation specialist. The same applies to operating the protocol manually, because laboratories usually have their own standardized versions managed by supervisors, and this makes reproducibility very difficult between labs and labs. So to tackle this issue, two open source libraries arose proposing different approaches. They are LabOp, a Python library that allows the user to create and translate a laboratory protocol to both machine and human execution, and PyLab-Robot, which is an agnostic environment for programming liquid handling robots. And it's currently operated in 3 types of machines from 3 different companies, those being Tcans, Opentrons, and Hamiltons. So the goal of this project is to develop a converter that will specialize LabOp written protocols into PyLab-Robot scripts, thus allowing the LabOp protocol to be executed in those 3 machines. The same applies to the Markdown specialization that LabOp has, that allows for manual execution. This converter will allow for the researcher, the PhD, anyone interested in executing the protocol to use a single interface for all those hardwares. So, to test this converter, we developed a DNA cleanup protocol. That is a model protocol that will be used to test the extensions. This DNA cleanup, albeit PCR protocol, makes use of an air pump module and an on-deck heater shaker module. The air pump processes and pushes the DNA and reagents through filters in the plate so the DNA can bind to those filters and thus allowing the cleanup process to happen. The heater shaker, on the other hand, incubates the samples on the final steps. Those modules are important to test the true extensions of the converter apart from just liquid handling operations. So, talking about creating the extensions, we first tackled containers that are used for experiments. First, we added new containers to LabOps OWL classes, so these containers can be assigned and used during the protocol. The containers that we added came from LabOps library of resources, in which LabOps manages the Cartesian location of a container on deck, and also width of the wells and all other special parameters, necessary parameters per se. We also mapped the actions and behaviors that are executed during the protocol, like liquid handling operations. Here we can see how LabOps operates at a higher level of complexity than Pilab Robot. The liquid handling primitive, that is the function that executes this operation, goes by transfer by map, which basically works with just a source and a destination as parameters. Whereas Pilab Robot works with 4 other functions, that is, picking up tips, aspirating and dispensing and returning tips, to execute what in a nutshell is the same function. So, the transferring of information was made based on identifiers in the configuration dictionary. Hello everyone! In the configuration dictionary.
There seemed to be, it cut you off, Luiza, right at 5 minutes. So I don't know what if that was an issue with your record. It looked like it was an issue with your recording. Was there anything else you had?
I just had one last slide I can show it live.
Yeah,
That's okay.
That's good.
Okay.
I wasn't sure. When it went off, that's why. Sorry, I went back. I was like, wait, did I just do something? I'm like, oh no, it was actually the video.
No, it's okay. Mind if I share my screen?
Sure, that's fine.
Gotcha. So I had we stopped at this slide, right? In the works.
Yeah, I think so. Yeah.
Yeah, we were already past the implementation and we were in the works. So what's missing here is some minor stuff in the specialization document, hence like debugging the full document, going through some minor stuff, generating the Pilab Robot script, and validate the serialization of the MP over pressure. That's like something more specific because we added on the specialization file all the informations that the air pump needs. So this way the user, when writing the protocol, doesn't have to do any of that. It just has to say this plate goes in this module and you can execute it. The last thing missing is the proof of concept. We will do that by decoupling the protocol steps. Both the modules, activations, and the liquid handling operations, and execute pilot tests for each one of those. So the last thing I wanted to do was to thank my mentors, Tim and Dan. They were really supportive to me during all the project, and they really guided me through something that was totally new to me at the time, and now I think I can go by with the basics. So if you guys want to take a look at more that PyLab Robot and LabOp have to offer, those are the links to their GitHub pages. And I think that was that.
All right, great. All right, we'll do the last one and then we'll open it up for questions. Thank you, Luiza, for jumping in there and doing that last one.
It's okay, you're welcome. It was probably with my old screen recorder, the issue.
All right. Next one.
Layout versus schematic visualizer. Hello everyone, I am Ismail and I am thrilled to be here as a participant in the Google Summer of Code 2023. Under the umbrella of the University of California Open Source Program Office, it has been a journey of learning and innovation, and none of it would have been possible without the unwavering support and expert guidance of my mentors, Cirimelli-Low and Vitor. Today I am here to introduce a groundbreaking tool that epitomizes the spirit of innovation, the layout versus schematic visualizer. It's a project that promises to significantly streamline in the process of layout versus schematic comparison, making it more efficient and user-friendly. Electronic design, it's really important to make sure a circuit matches its original plan, but many professionals spend a lot of time finding and fixing design errors, a task that can be complicated and slow. So this is the screenshot of the schematic and layout netlist comparison file. Imagine having to look through a really complex file. It's full of technical details and connection, trying to spot the differences, and errors in the file can be like looking for a needle in a haystack. It's a time-consuming and tricky task. This is the problem we wanted to solve when we created the LVS visualizer. Enter the LVS visualizer, a tool where innovation meets practicality. With its user-centric design, professionals can now effortlessly compare schematic and layout netlist, eliminating the complexities of sifting through complex data, and interactive nature of this tool ensures dynamic feedback, fostering an enriched user engagement experience. Moreover, its integration with Magic Layout provides a real-time insights, marking a significant stride in circuit design validation. This is the LVS visualizer interface. With the LVS visualizer, checking and fixing your circuit design is a breeze. It lets you easily see and understand the difference between your planned design and the actual layout. No more headaches trying to read complex data. This is the screenshot of Magic interface. It works hand in hand with Magic. You can click any net device or printable highlight in the Magic layout. The LVS visualizer is not just about a user-friendly interface powered by Python, ensuring logical operation are swift and error-free. The PyQt5 framework amplifies its interactive capabilities, making real-time feedback a reality. Moreover, this synergy with Magic software underscores its efficiency, where discrepancies are not just identified but made visible in the layout instantaneously. Creating the LVS visualizer involved a lot of research, multiple design attempts, and clever engineering. We spent time exploring tools and data, making algorithms to show netlist data easily, and building a user interface that's easy to use and understand. Every step from getting to know the data to combining the tool with Magic was carefully done to make sure the tool is not only useful but also top-quality efficient. I cannot end this talk without expressing my deep gratitude to my mentors. I am also immensely thankful to Google Summer of Code and University of California Oxford organization for providing this incredible opportunity to contribute to open source and make a tangible impact. This journey has been both challenging and rewarding, and I look forward to seeing how the LVS visualizer will benefit the circuit design community in the future. Thank you so much.
Great. Well, that was our 4 lightning talks. think we have about 10 minutes or so. I think we were over a little bit, but I think if that's okay with everyone to stay on to any questions people might have specifically for mentors or the students that are on. They're actually, aside from Luiza, I see that Jessie Lima's on, who was a student. And also, is there anyone else that I'm missing that's also on that's involved? So we have a number of mentors, actually a good chunk of mentors that are on too. So any questions specifically to those who was presenting, that'd be great. Or and just general questions for the mentors and the students involved, sorry. I have a question. I liked for Luiza, you mentioned the fact that you felt that you really went from, felt that you went from like 0 to 60, as we would say in the US, so very fast, like learning curve. Is that, would you say that that would be a good assessment of your of how you felt? And also where do you think what helped you the most? I think getting, because you have a successful project, you got your everything in on time, and in the end, so where would you think like how would you best describe your kind of feeling about where you were the beginning and how you are at the end now?
Oh no, at the beginning I was completely lost because I don't come from a coding background and I just knew minor stuff before joining the program. So I think this is like a great example of group work, because I know it wasn't only the institution, but it was also my mentors who helped me out through every single question that I had and were always there for me. Also, it was what improved the most was the communication. I learned how communication and information is shared during the development of a software or an extension per se. And learning how to manage that was, I think it was the breaking point between the slow start and the big gap of progress.
Okay. Yeah, that's great to hear too. That's part of the whole. One of the main goals of the project, the program itself, I think, is to help move folks, and it's good to hear that like it was a team effort to get there. Just look. Sorry, I'm reading the comment from Emily. Oh, she was just saying she had to head out. Other questions or comments, or if any of the mentors, especially maybe Tim, if you want to talk a little bit. Actually, I might actually do this. I might go ask the mentors who are on, whose students just presented, to kind of give like a little bit of an impression, or any other explanation about what they might want to add about the projects too. So I'll start with Tim, since we're talking with Luiza, if that's okay. Sorry to put you on the spot, Tim.
No worries. Yeah, so I think the project went super well. I think in biology, it's always challenging to find, the talented people that have a foot in both worlds, right? The world of software and also the world of wet laboratory biology, which are pretty distinct, and oftentimes people aren't trained in both. So I think Luiza, there was definitely a learning curve, but I think she started actually from a unique place. So she shouldn't sell herself short that, she had to learn everything. I think a lot of biologists would be terminally challenged by the the project that Luiza took on. So very happy with the results, and yeah, Luiza is a great student, so good job.
You're getting a lot of hearts, Tim, if you're not seeing them. Great. So can I put Jessie Cirimelli-Low on the spot too to talk?
Yeah.
Yeah.
So I guess the LVS schematic visualization project came about from TAing VLSI courses and mentoring new grad students in my lab. And we really identified LVS as something that was conceptually pretty simple. I mean, you're just in the end of the day comparing two graphs, but in practice, it was pretty difficult to do. And this was largely because of the archaic nature of some of these EDA tools, both the modern ones and the old ones, I would say. But some of the older open source ones are pretty feature rich, but have a pretty high barrier of entry. So we went in with the goal of trying to lower this barrier for people interested in VLSI. And this was my second year as an OSRE mentor, and I think we learned a lot from our mistakes in the previous year. Last year, we had a task that was conceptually pretty simple, but tightly coupled with our code base in a way that made it pretty unapproachable in the span of 10 weeks. So this year, we picked a task that we tried to scope a little bit better and something that could be presented to the contributor in an abstract way. And have a somewhat standalone result that could then be integrated with our larger tool chain. So I think that methodology made this year's project a lot more successful than our previous attempt, and something that we'd like to continue doing in the future.
Great, that's really good to hear, the way that you were able to learn from last year too. So, and it's good for us to take on also as things to make sure that we discuss with new mentors coming in, like, hey, these are experiences of other projects have had, so it's really good to hear.
Thank you.
I'm also going to ask Vitor real quick to kind of go over putting you on the spot. Sorry.
No worries. Yeah, I think it was a great opportunity. And Jack was a great match also for the project that we proposed, especially because although he had some understanding of the EDA world, he didn't know the tool very well. And since the goal of the project was to improve the entry-level steps into the OpenROAD world, having him not know a lot about the project was great, because while he was documenting the process of installing OpenROAD, he was able to find issues or pain points and we were able to address them over the course of the project.
All right, that's great. Yeah, I like to hearing. Yeah, there's really good feedback and hearing how all of your projects progressed and how the different how everybody fit in really well. I'm going to open it up to other folks for questions or comments from other mentors and students that are on. So anyone have a comment, either people who weren't involved with the program, who might have questions about the work or the program itself, or anyone who has comments they want to make about their experience this summer. And yes, we will do it again next year. No? Double checking. Well, I have to say that for me, and feel free to anybody still thinking of something to jump in. For me, it was a really great experience. It was a lot more than I usually have, and because summer reproducibility was a large group of folks that were separated from the GSoC folks from an administrative perspective. I had to deal with a lot more issues, and I appreciate all of the students' patience on a lot of the admin issues that were new to us as an organization having to deal with, where a lot of times when we mainly dealt with Google Summer of Code, they deal with all of those administrative issues. So I appreciated, I had a lot of very, very patient students, and I really appreciated all of them. But in general, I heard great feedback from all of the students. I really appreciate. So any of the mentors on the call, you all did a great job. I was very impressed, and everybody was always very, all of the evaluations I would get back that I would see either for any of the OSRE, students that we were working with, were all very, very positive about how their mentors worked, how their mentors were supportive. And that was really, really good to hear. And then, overall, the positive responses from the mentors also make us happy, because we want you all to come back I mean, and so that you had a positive experience and you had a good experience with your students and the students helped you in your project and what you were working on. So that's always really, really good to hear. So, and yes, like I said, we will be doing this. I mean, God willing, we will be GSoC mentor organizations in 2024. Again, it's not always guaranteed, but it's definitely something that we always push for. And now that the bigger we are, I find that the more, I don't want to ever say what you are assured to be a GSoC mentor organization. They like to cycle through and bring new blood in, even if you did a great job the year before, which I think we can say we did this year. But but generally speaking, I think that from the success we have a very good track record with them, which is always good. But also Summer of Reproducibility, like I said, is a multi-year program. We will be back next year. So for those of you working in the reproducibility world, spread the word. It's what's great about that program is that we can work with anyone with a very few limitations. So, and people can reach out to me already about that program. And then other projects that somehow don't fit under GSoC and don't fit under SOR, but are some OSRE type programs will be also open to working with, and we look forward to even more students than the 38 we had last year, this last year. All right, well, if that's it, then I'll let everybody go. We have about 45 minutes until the next session. I'll just as before, I think I'll probably just leave the room open so people can actually just stay here, come in and out. If people for the next session need to practice any slides or anything, or that should be fine. So anyways, I'll wrap up until the next session that starts at 1 o'clock.
Hey, can I say something?
Oh, sure.
I've just been lurking in the session, listening to other mentors and students, and it's really impressive. I just want to say thank you, Stephanie, for the whole summer. I don't know how you manage all these programs together, and I think we all benefited from it because just all the nudging you do to keep us going forward.
Please put your evaluation in on time that you got yesterday.
Yeah.
I feel like I was a little less good about it this year because I had the one thing I noticed with GSoC this year is because they allowed for, and then for OSRE in general, is because we allowed for different end dates, that it changed the way the evaluation schedule was, and that's new. We had it last year, but this year it really became much more complicated when I had to actually try to remind people. And I know you all get like reminders. The GSoC folks under the GSoC umbrella were getting reminders from GSoC, but the folks from SOR, I kept, not getting the reminders out on time. So luckily, everyone was really, really good about getting them on time. So
reminders
I appreciate that.
And we academics always work on the last minute and like
that's not good for my heart.
So but it helps to have that level of check.
Okay, great. Well, no, thank you again. Thank you to everybody. It was a fun experience. So, and we'll try it. Like I said, we'll try and get together to do kind of a debrief, and maybe one big organizational kind of Zoom call to try and have everybody kind of chat and see and get experience from the students as well. That'll be a really big call considering we had 38 students and I think like another 40, almost 40 mentors, maybe a little less than that, but it was a lot of people. So. All right, great. Like I said, all right, so I'm gonna go. Oh, Carlos, did you want to say anything? You just turned.
Yeah, I think I want to just follow Oscar's example and shout out a big thank you to you and to all the mentors and all the students, and really hope that you're going to join us next year again.
All right, great. All right, so we'll wrap up this now, and like I said, the people can keep talking, but the session will be over. All right. All right, thank you, Tim.